Okay, now we are going to look at an important and less talked about function of the OS, if I may say so. It's the timer. So before I directly explain what the timer is, we were talking about process scheduling, right? And resource allocation. So the OS tells the CPU you're going to do this task using these resources from this time onwards. So let us assume the OS tells the CPU that the CPU takes up the task, it takes up whatever resources it is given, and it starts working. And for some reason, let's say the process gets delayed, some delay in the input or in accessing the memory. Let's say it looked in the registers, it looked in the cache, it had to look a lot of places before the memory was accessed, and for some reason the process keeps getting delayed indefinitely. At some point the CPU should stop, right? It should say, okay, there's something wrong with this process. I cannot proceed with it with the resources available to me or without some intervention from some force. So let me stall this process and let me move to some other process. The CPU has to make that decision, right? Otherwise your browsers would keep loading indefinitely, and at some point when there's no internet or something and you try to load a web page, you get a pop-up saying this tab or this URL has stopped responding. Do you want to wait or report or try again later? Or there is no internet, please check again later. You get some alert, right? So if that alert, you get it because the CPU realizes that something is wrong with this process, and at this point I should stop trying for a bit and I should let the user know that I need some intervention, I need some support or some resource which is not available to me right now, so I cannot execute this process. So if the CPU does not make that decision, it will keep trying to run that process indefinitely, and if something is wrong with that process is not going to get executed. The CPU is not going to be able to take up some other process and work on it either. So your time, the computer's time, resources, everything is getting wasted, and the net output, the tasks performed, would be zero. So to avoid that, you have to ensure that no process gets to claim an unlimited amount of the CPU's time or resources. So you have to ensure that every process is allowed only a specific quantity of the CPU's resources or computational power, and only for a limited amount of time. If within that amount of time the process is not able to finish execution, the CPU must stop working on that process at that time and move on to something else, and probably raise an error or alert saying this has not functioned the way it has to. So for that, we have something called a timer allocated to every process. So when a process begins execution in the CPU, the timer corresponding to that process begins, and the clock starts ticking, or the countdown happens, so to speak. When the process finishes execution, again the timer is reset and the next process comes. If for some reason the timer comes to 0 and the process has still not finished executing, then the process is stalled or it is stopped midway there. The control goes back to the CPU or the OS. That process is pushed out of the CPU and another process is brought in. Why is this necessary? Because, like I said, if you do not have a timer and if something is wrong with the process, it will keep executing indefinitely, and you will never be able to get anything useful done. It is just a waste of your time and the computer's resources. So there is a timer associated with every process. Let's say for some X units, X seconds, milliseconds, whatever. If the process finishes whatever it had to do within that X milliseconds, well and good. We move to the next process, again another X milliseconds. If the process has not completed its task within X milliseconds, it will be stalled, abruptly cut off there, and an error message or alert, if applicable, will be put up, and the OS will direct the CPU to take up and work on the next task. So this timer, setting the timer at the start of execution, maintaining the timer, flushing out the current process when the timer becomes 0 and bringing in a new process, this part is done by the OS. So this is an important function of the OS. And now that we are talking about the timer, I think this is a good time to introduce another concept called user mode and kernel mode, which is quite related. So the idea is not all processes must be allowed access to modify all parts of memory. So this goes back to the same idea. No process should get to claim an unlimited quantity of the CPU's time or resources. So we talked about the time aspect. We know why every process should only be given a limited amount of time. What about the CPU's resources? If every process was allowed to access any part of the computer's memory and modify it, then some random user process which you give can go and modify the OS itself, right? So you can write a code or some virus, some malware can be programmed to access the part of the memory where the OS is stored and to rewrite that itself, which means your system is being hacked, your personal information is being accessed, which is basically not a safe situation, right? So for every process there is some amount of data or some locations of memory which it has to access, which it should be allowed access to, and there are parts which it should not be allowed to touch. So every process should not be allowed to access every part of the CPU's resources or the memory. So we have something called user mode and kernel mode. So this is best understood by looking at your computer login. So you have different things, right? You have admin, you have guest user, there are different levels. So if you log in as the admin using the admin's credentials, you can perform almost all changes, all configurations can be modified. If you are logging in as a guest user, your privileges are restricted. You will be able to access the application software, but you will probably not be able to make changes to the system or the configurations. Similarly, the processes also have varying levels of privileges. So some instructions can be allowed to access different parts of the memory. So if the OS is giving an instruction regarding process scheduling, it should be able to access the different processes, their instructions, their memory locations, everything. It should be allowed access to almost everything. But if the OS is asking a process to pick up some data and perform an addition operation, that process should only be allowed access to the two operands used for addition. It should not be allowed to alter the OS itself. So different instructions should be allowed different levels of privileges. Different processes should have varying levels of privileges, which is why we divide our processes into normal, like ordinary user processes, and privileged instructions or privileged processes. So the privileged instructions can only be accessed through something called the kernel mode. So just as you have guest user and admin user in your system, the OS has user mode and kernel mode. So the user mode is like analogous to your guest user login, where you can perform basic tasks but you cannot change major configurations. The kernel mode is analogous to your admin login, where the OS can perform any task, modify any sort of the memory. So when you have a user process, if you look at the diagram here, the user process wants to execute, it gives a system call or a command. This is happening in the user mode. The gray rectangle is your user mode. So there is a process in the user mode, it gives a command, the kernel goes into the kernel mode, it will perform the privileged instructions required, then it comes back to the user mode and the control goes to the process and the process does whatever else is required. So for example, if there is a process is created at this point, the process is called, or it is ready to be executed, it has all its data. Now the kernel goes to kernel mode, it picks up this process and it allocates it to a CPU. That happens inside kernel mode. Then we come back to the user mode and the CPU will execute this process. So execution happens in the user mode. So this process which is running right now cannot alter any critical information. But the allocation happens in the kernel mode because that is a privileged or a critical instruction, and that should have access even to your sensitive areas of memory. So that is the user mode and kernel mode. So those are two modes of the operating system.